about. I will talk about FreeIPA, and you will understand why soon. We'll talk about what are cross-forest trusts. Maybe not everybody really know what it is. What are the protocols used? This is a protocol Plugfest after all, and I wanted to give you an idea what protocols need to be used. A little bit in detail about details of trust relationship, one-way or two-way trust. Let's see why we talk about that. Then mapping users from AD to Linux client, and then finally some words about Samba and cross-forest trusts. Before talking about these topics, I need to tell you why it is interesting for me and why we need to figure out how to do AD forest trusts. This work has been developed after the first attempt in the FreeIPA project to gain interoperability with Windows Active Directory by implementing all the Active Directory protocols. This work has been done in the Samba community, and we wanted to reuse kind of this work and lay it on top of the FreeIPA project, but we failed to do that for a number of reasons, and so we switched to another approach, which was, well, let's just interoperate with Active Directory so that we have Active Directory on one side and FreeIPA on the other. And it was fundamental for us to have a good experience for the users. So Active Directory allows you to do something with the MIT KDC, which we'll see what it is. It's called external forest trust. I want to give a framework for those that know what this is, or those that don't know. This is not the external forest trust. This is an actual native forest trust, which is a little bit more complex as a protocol. So for those that know what trusts are, this is not the other kind, the simple kind. This is the full integration. And I want to talk. I want to thank Microsoft actually for having out the Doc Help program. Has been a very useful thing. Without it, it would be much more difficult to do any protocol work. And so I think they deserve a thank, because their engineers really help when you're stuck in something. Even when you just read the documentation, sometimes the documentation has bugs, and being able to ask them, I mean, is this really correct? Because we're trying to use it and it doesn't work. And they are very, very, I would say, fast for what is a kind of an industry standard, and they're always very precise, very deep. They can get down to the deep level of the protocol and tell you, yes, this is how it works, or no, we have a bug, and we will document why Windows is doing that, this or that, and it's been really useful. So let me try to explain you what is FreeIPA and why I talk about that in the terms of forest trust. So FreeIPA is a directory authentication server, or as you might call it, the domain controller in Windows terms. Is the goal of the project when it started was to provide, really, you could say, a domain controller for Linux workstations or Linux servers, rather than workstations, really. And it was born out of, I would say, basically necessity. The FreeIPA project decided to build this kind of domain controller as a meta project using existing components, and so it's really about getting a ton of existing components interoperate together. The main work was, let's take all existing open source components and create a sort of domain controller for the Linux server environment that can operate more or less like Active Directory does for Windows clients, but specific for Linux, using open standards and using existing components and making it actually simple to use. So we can see that we have, this is a simple schematic of what FreeIPA basically is. It has a directory underneath, and in our case we use an open source project called 389DS. And then there is the authentication part called MIT KDC. Then there is a DNS using the Bind project, which is also a very well-known open source project. NTPD. There is a web UI using Apache, Python, other open source component, and then there is DocTag, which is a certification authority. All these components existed before we created FreeIPA, but they were all single projects. You had to know how to use every single one of them. You had to understand how to integrate them manually, how to configure so each one would talk to each other. And it was really complex to try and do that. When I started this project, after a few years and building it, we found out, we counted one time, how many steps you had if you wanted to manually integrate all these projects, make them all interoperate. And it was like 150 different steps. And they were not just like simple commands, they were actually complex steps. And if you try to do that on your own, it would take probably a couple of days to set up one server. And that doesn't count replication, multiple servers. The FreeIPA project was able to put all these projects together, build glue code where it didn't exist to make things smoother. And if you want to install it today, it's 5 minutes. It's like you run a command and all these things come up and they work together very well integrated. So I think it was really useful from a learning point of view how to integrate really software together. So interoperability was possible thanks to open standards, but also to a lot of work to make these things really work together. So it's like taking all the Legos, put them together with the instruction sheet, and having your beautiful, Lego project, whatever. Except that you don't have to learn how to build a thing, you just have the instruction manual ready for you. So some defining features of why we created this project, and why didn't we just go with something like Active Directory. And so as I said, we wanted something specific for Linux servers mostly. And for us, the defining features were security features that are related to Linux specifically. In some cases, these things do not exist on Windows or do not really apply to the way Windows works. And so we built something like host-based access control, because for our purpose, getting to know who can access what, which kind of machines can be accessed, was important. Centralized sudo policy. Sudo is something that doesn't exist in the Windows world, but it's very much used in the Linux world for administration purposes in order to gain privileges from a user to admin to perform privileged operations. Group-based password policy, and then later on two-factor authentication, for example, directly built into the OS. SSH key management. This is also something that is not really something you see much in the Windows world, but it's basically what every single admin does on Linux machines. They use SSH keys to log in from one machine to the other and do administration purposes. And we have it all integrated in IPA so that it can be controlled centrally and distributed all the machines without having to manually go and configure every single machine. And then delegation of all these administrative roles you have in a fine-grained way, so that you don't have just root, and root can do everything. You can have different privileges distributed among higher or lower level administration. Plus, we had other things that were really even desktop at all, like management of SSL certificates. A lot of Linux machines are used, for example, as web servers. And what you want to do when you have a web server is to have an SSL certificate so the clients can connect securely to the web server. So we built a whole lifecycle around SSL certificates so that they can be basically automatically provided to the machine you install when it joins the Linux domain, and then can be managed, revoked, and all that. And recently also we started playing with DNSSEC. DNSSEC is something that is kind of coming. It's a very important security feature that was lacking in this very important component of the web. If you know what DNS is the thing that really works when you insert a name in the browser to reach a server. That name has to be translated into an IP address. And the way the current protocol works is that anybody between you and the DNS server can basically inject a different IP address and change it. So it's attackable, it's a point of attack. And it's not really fatal in the sense that most web servers will use HTTPS. And so if you try to redirect the user somewhere else, the browser will notice that the name and the certificate does not correspond. But there are other services that are not HTTPS. They also rely on name resolution. And so DNSSEC is a way to sign the mapping between the name and the IP address, so that when you ask the DNS server what is the IP address of a name you're using, you can be cryptographically certain that the answer is right. And so we've we've built a way to automatically assign the zones within if you use the FreeIPA DNS server, so that you don't have to manually do all the management of the security part of DNS stack. You can basically enable DNS stack with flip of a switch and have all your names within the enterprise cryptographically signed and distributed. I think this is a really cool thing. So these are all features that are really very Linux centric. They are not something that exists in the Windows world, and we wouldn't have them if we went and built just a cloud. So these are just the reasons why we created something different. However, we still have a problem. We need to talk or interoperate in enterprises where they already have an install base and all their users are in Active Directory and their desktop are Windows, and they have no reason to change that. They are fine. They like it. It works. From the desktop point of view, Active Directory has a very specific and very useful features and software that integrates with the whole ecosystem, so they don't want to change that. But they have a lot of Linux machines, and they may want to use something that is Linux specific. So how do we bridge the gap? How do we interoperate? And so we came up with this plan to build forest trusts. So what is a trust? In a nutshell, it's just a way for admins of the Active Directory world and the admins of the Linux/FreeIPA world to agree that each side recognizes the users and the computers of the other side. How it's done is done at the cryptographic level. Both Active Directory and FreeIPA use something called Kerberos as the authentication protocol, mainly. There are other protocols, but that's the main protocol. And we just set up two keys on one on one side, on the other side, so that when the two systems talk to each other, they can actually trust that whatever information is coming from one side is really coming from that side, and vice versa. And when that information is coming, one of the systems trusts the other. So when a user coming from the Active Directory side talks to the FreeIPA side, we can trust that user is who the Active Directory domain controller say it is, and then just let him in and work. And one other thing that is kind of important, at least because for our customers, is that forest trust can be one way or two way. What does it mean? It means that you can trust only Active Directory users talking to the Linux side, but not the other way around if you want. And that means that you have a one-way trust. So the trust flows only from one way to the other and not vice versa. While if you have a two-way trust, then you could say, well, also the Linux user can be recognized on the Windows side. And so if you have a user that is created and built on the Linux side, it could theoretically log in on the Windows desktop as its own identity. So you have the choice of whether going one way or two way. And the final point is that we talk about forest because in the Windows world, we have domains, but you also have all the you can have multiple domains in a forest. It's like a forest, like you have multiple trees and stuff. And this organization is such that you have a parent on the top called the root, and then you have these multiple domains. And forest can be only cross-forest trust can only be done at the root level. So you have to trust the whole tree down. It cannot be done at a small level. That's sometimes important to know. So this is a visualization of how this kind of works. It's important to understand that when this is in place, you have this world split in two. You have the users on one side connected to an identity silo, if you want, to maybe Active Directory, and then you have this, let's say, web server on the right side connected to the FreeIPA server. And the user keep authenticating all the time to its own Active Directory thing. It never does anything on the other side, but still can access directly the resource without having to do any other authentication. It's automatically recognized. And if you use the right protocol like Kerberos, you can have actual single sign-on, meaning that the user really doesn't have to enter any password or anything. It is automatically recognized on the other side. And this is really important in many cases for actual practical everyday usage. If you had in your own company to every time you go to a server or website to enter your credentials manually, you will get crazy pretty soon. If every time you go to a web server or of many, you have to put your own username and password in just to do something, you would probably stop using it, or worse, you will start trying to use the browser to save the password in the browser so that it doesn't ask you that. And we wanted to avoid that, and that's how what you do with a trust relationship. You don't have to do any of these. The user is automatically recognized because of the way Kerberos work, without going too much in detail. So the whole point is, how do we do this? How do we make Windows talk to FreeIPA and vice versa? In the Windows world, in Active Directory world, cross-forest trust already exists. They already had this problem of having multiple silos themselves within their own products, without their own domain. Like if you have multiple companies, joining together, they have to actually kind of talk to each other. And so they have built, in part on standard protocols and in part on our own protocols, a way to have the multiple Active Directory forests talk to each other. And so we basically had to discover what was necessary, what was useful to use from these protocols, and try to use some of them so that the Active Directory on one side could talk to our server on the other side. And we did it in a way that the Active Directory for Microsoft doesn't really know that FreeIPA is not another Active Directory server. It thinks it is. And that way we trick it to basically behave the way we want and just work without having to change anything on the Active Directory side, which is useful because having to ask people to change their own things is often very difficult. So what are the protocols that are actually really needed if you want to do something like that? There are two that are foundational, I would say. One's called Kerberos and the other is DNS. And there are some that are AD specific, and they are not always technically really necessary for the functioning, or at least at the authentication level, but they are necessary for some of the operations you want to make simple. So Kerberos. I won't go into explain what Kerberos is. For the non-initiated, it's just a way to perform authentication over a network without your password ever leaving your machine. You can think of it as magic, effectively. Because if I had to go into the crypto, it's going to be crazy. The only thing that is really important about Kerberos is that every single user or service in a network, like every computer, has an identity into the KDC. So basically the Kerberos server, which is Active Directory server in the Active Directory case, or FreeIPA in the FreeIPA case, know about users and computers and services, and has a key for each of them. For users, the key is their password. And for machines, they have just a password equivalent stored on the machine itself. And every time you need to talk to some of the machines, you go to the KDC and ask the KDC, please give me a ticket to talk to this machine. And that's how the magic of not having to enter the password again works, because your machine knows how to go to the KDC, ask for this ticket automatically, and then go to the service and say, hey, I'm this user, trust me. And all of these work. When it comes to real trust, we need to add an additional step. So we go to our KDC and say, hey, I want to talk to that guy there. And the KDC says, well, yeah, okay, but that guy is not in my domain. I don't have any key for that. And so I need to give you a key with which you can talk to the KDC on the other side. And then he will give you access to the system. So basically, we have to create this identity that identifies the whole other forest to your own KDC. And that way you keep going and get tickets on the other side. So that's the main thing when it comes to the Kerberos product. You have to implement this whole forest identity in your own KDC. And you exchange these two keys between the two parts, the Active Directory KDC and the FreeIPA KDC. And from that point on, at the cryptographic level, we can talk between the two forests, between the two domain. And if you exchange both keys between both sides, you can have a two-way trust, because you can go one way and can you come back. If you share just one of the keys, you can go only in one direction, and that's how you can decide whether you want to trust both directions or not. This is a diagram of what happens when a user wants to join the other part. So the first part, the blue part on the left, is just the user doing normal authentication against its own main identity sealer. So you just go to Active Directory, get a ticket, and then talk to the machines on that side. Then comes the moment where you have to talk to the other guy. And this is where these two keys that I just described come into place. So you go to the Active Directory domain controller and say, I want to talk to the Linux server on the right. And it will tell you back, well, this is the key to go talk to the other KDC. And so you go there, the green line, and the other KDC will say, yeah, I recognize this key. This key is the trust key, so I can allow you in. And it will give you a way to talk to the final server. And this is completely transparent. The user doesn't see this. Only the user sees, oh, I'm browsing to that server. I'm accessing that file share there. But this happened under the covers, and it just works. But in order to work, we need another piece that is also fundamental. I told you that the user wants to go and say, oh, I want to talk to that machine. And how do we reference a machine is normally through DNS. We need a name to be able to access a resource. Otherwise, how does the computer know where to go? And as I said before, DNS is the thing that translates names into IP addresses. But the other important thing is that it actually gives a name to a machine. And the name is important because back to the KDC, you have identities that are tied to machines, and those identities are recognized also by name. And the same name that's used in DNS is also used in the KDC to reference the machine key. And having DNS working is fundamental in order to be able to actually get the whole transparent authentication working. If DNS is broken, nothing works basically. So DNS is fundamental, and that's why it's in one of the foundation protocols. And both Active Directory has a DNS server for that reason, embedded in, that you can install, and FreeIPA also has a DNS server embedded in that you can install. And the reason why both products, I guess, at least from the FreeIPA side, but I bet it's the same for Microsoft, is that by embedded into the main controller, we make it easy to basically have it working right, without having to depend on an external admin to configure properly the things. Just by joining machines, you have them create an entry in DNS so that the user can actually reach those machines and know that it works. And one of the things that keep the whole thing working is that machines can update their DNS record. So if you move the machine to another part of the network and the IP address change, the machine will autonomously connect to the KDC and say, hey, I have this new IP address, so update DNS so that DNS point the user to the right place when they want to access some resource. And then there are the ID-specific protocols. CLDAP is one of the simplest ones. For those that know LDAP, Lightweight Directory Access Protocol, is just a product that allows you to go to a directory that contains user, machines, other data, and ask for information. LDAP, though, is use streams, use a TCP connection, so you have persistent connections. While CLDAP is more or less the same thing, but running on UDP, it's datagram protocol. That is connectionless. You just send a packet and you hope that the server will reply. Usually it does, sometimes it doesn't. But it doesn't matter. If it doesn't, you will retry again later. And this is used in the Microsoft world to find out exactly which domain controller you should talk to. In big forests, you have multiple domains, and in each domain you have multiple domain controllers. And as a client, you need to find out which one should I talk to. I mean, we cannot go all to the one place. So in Microsoft terms, there are things called sites, where you can basically partition your install base in multiple different sites, and then each machine needs to find out which is the site they belong to, so that they can connect to the domain controller usually closer to them. And this is done through this protocol mostly. The client will send out this ping to the first domain controller they can find in DNS, and then that domain controller will reply with a message say, well, you should go there. And then after that, the machine starts talking to a specific domain controller that usually close to them or faster for whatever reason, whatever the admin decided. And Windows clients will do this, and Windows domain controller will do this also for cross-forest trust. They will want to find on the other side who they have to talk to when they have to talk to the other side. And so this is something that you have to implement if you want to have this thing working. MSRPC. So this is the most complex part when you take on this trip. So technically, just for the authentication and all that, Kerberos DNS are sufficient. But when you want to actually set up a cross-forest trust, the Windows domain controllers need to talk to each other. And because Active Directory thinks that for the purpose of the trust, the FreeIPA domain controller on the other side is also Windows, they want to talk to the other side to set up this trust, to exchange the keys. And the important thing is that you can initiate this trust from the FreeIPA side, for example. But in any case, they have to talk back. So it's both ways. You have to implement the whole stack on both sides. And so both as a client and as a server. And so one of the things that are fundamental and for which this thing is needed is validation. So the MSRPC stack on the FreeIPA side uses Samba in this case, in our case, and the call that is done on the so-called net logon pipe is this net logon control 2x call. Just one of many. You don't have to implement them all, but what this call does, it allows the Windows DC on the other side to try on a protocol that it knows whether the domain controller on the other side really knows the secrets. It's called validation. It's a step that is fundamental for the setup of the trust the first time. You do it when you do the setup. And if you don't have the SMB stack on your side, even though you enter the password manually into the domain controller, the Windows domain controller, and even though it knows that it should talk to you, it will not. So when you go to when you have your Windows client and try to talk to the other side, the Windows domain controller will just refuse to give you a ticket to talk to the other side until validation is performed at least once. And so we had to build the whole stack, and instead of rebuilding from scratch, we said, well, we use the Samba SMB, the server, which implements the SMB protocol, which is necessary to do MSRPC on top of it. And the only thing we did is we built a little bit of glue called PDB, which is a small module that allows the Samba daemon to talk to the FreeIPA LDAP server and get the information it needs to return to the domain controller on the other side. This is not user application, this should be domain controller. Oops, little mistake. And so all we had to do is to build this little PDB square into Samba, so it talks to FreeIPA and the whole thing can work, and the stack is used from Samba. This is another part of the integration work we had to do to build this stuff. We didn't rebuild the whole SMB-RPC stack. And the same thing happens the other way around. So one of the things we need to do is to tell the Windows domain controller which domains we handle on our side. When the Windows client wants to talk to a machine, it will give the Windows domain controller a name. I want to talk to this machine at this domain. But the way the domain controller knows where to send further this machine in order to get there is to consult a table. It's called routing table, in the trust routing table that tells them, oh, okay, this domain is handled by this trust, so you go to this server, even if this trust handles multiple domains and the main name is not the same. So we basically use this other MSRPC call to tell the domain controller, we handle domain A, B, C, and D. So if the user ever asks for you for contacting one of these machines, send them here. And you have to tell the the Windows domain controller, the whole list. Otherwise, it will not send the user your way. And the only way to do that is again to use an RPC. This time as a client, you have to send this list using an RPC call. And in order to do that, you have to have the whole stack again as a client. So you have to talk SMB, you have to set up an RPC open RPC pipes and RPCs back and forth, and then the Windows domain controller is happy with this information, and from there on it will send users your way. Finally, the global catalog. This is something that is specific to Microsoft. It's just an LDAP server in the end, but in an IoT world, what the global catalog does at the forest level is it has a summarized bunch of information about multiple domains in the forest, if you want, and so that a client can just ask for a global catalog about information about multiple domains without having to contact every single subdomain. This is necessary. This is not necessary to establish trust. In fact, we don't implement it in FreeIPA yet, so you can work without it. The limitation, though, is that you cannot really do a full two-way trust without it, because one of the key things that the global catalog allows you to do is to transform a name, like a username, in what Windows used for security, the security identifier. So when a user tries to log in, for example, if you had let me go to the next slide. Yeah, if you want to log in on the Linux side, what we do is that the client, the user comes in, will present the ticket, so the authentication succeed, but we still need to know who the user is. We need to know things like what are your IDs, what is your home directory, and stuff like that, information that belongs to the user. Some of that information comes into something called the MS pack within the ticket we give, and some information we need to gather from the LDAP server on the other side. Now, the global catalog what gives this information. So we get user like Jane ID, and we want to know what are the seeds connected to this user. We can go to the global catalog and ask, okay, we have this name. What is the seed connected to this name? Or vice versa. In the pack, there are things called group seeds, which identify the groups of the user. We might want to know what is the group name, because we want to show these groups to the user for whatever reason. Maybe the user wants to set access to a group on a share or something. They have to know what the group name is, because they don't understand numbers. Numbers are really long and difficult to use. When you want to give access to someone, you say, I want to give use to the domain users this file, or maybe the domain admins, or maybe the finance group, or whatever. You go by names. You don't go by security identifiers. And so the way what allows you to resolve these identifiers into name or vice versa is the global catalog. Now, if you miss that, you cannot add, you cannot resolve names into groups, and that means that the Windows management tools do not allow you to do things like, allow all the users from the FreeIPA side to log into this machine, because you have no way in the management tool of Windows to add the group of users to the access policy. So that's what it's useful for if you want to go the other way around. And we don't implement it yet. We're planning to implement it. So for now, for example, the FreeIPA project is basically limited to OneWay Trust for users coming from AD inside. Once we'll have the global catalog, we'll be able to do the full two-way trust the other way around. So it's not fundamental, but it's necessary nevertheless. And so we talk about two-way trust. Why it's important? Well, besides the request, the reason why people are hesitant sometimes to allow you to set two-way trust is that you may have Windows admins controlling the security policies for their domain, and they don't want you to have FreeIPA server serving users they don't know of and letting this user access the Windows side, like logging into desktops and stuff like that. And of course, you could set security policies to not allow that, but it's even easier if the server on the other side have no technical means to really give access to those workstations. And so when we first implemented this trust stuff, we by default went with the two-way trust setup, meaning that when you set it up, it's just two-way, because we set all the keys. And then we had a few deployments and people coming back asking, well, we would really want to limit that, and we would really want you to not be able, even in principle, to access domain on our side. So we had to start supporting OneWay Trust for real, meaning that cryptographically we wouldn't have the means to access the Active Directory on the other side. And so there is just one problem. We still need to do the thing about resolving users when they try to log in on the Linux workstation. And that means having to go on the Active Directory side and ask for information. Now, normally, the way you might do that is that you just go straight to the Active Directory server and ask, oh, who is user J? What is it said? Little problem, in order to do that, you need to authenticate. And now if you have a one-way trust, it means that the Active Directory server does not trust anybody on the other side. So you cannot go there and ask anymore. Head scratcher a little bit. How do we make this thing function without having access? It's really not that difficult in the end, but it requires a bit of infrastructure. One of the things we did right, even when we built the two-way trust, is that instead of having the client go straight to the other domain, we always build our client to go and ask our own server first, and then have the server do the actual request on the Active Directory side. When we did that also as a way of caching information, so that we wouldn't always hammer the other side. But it came useful because now we have a single point where we gather all these requests, and then the FreeIPA server can go on the other side and request information using authentication, but authentication that only the FreeIPA server can do. So basically we have one account in the FreeIPA server that is set up automatically when you set the one-way trust, and that account is allowed to go to the Active Directory side and ask, oh, who's Jane, who's this Sid? But only the domain controller can do that, none of the clients on that side. And so the clients only rely on the domain controller on our side to get that information. It has to come from domain controller. And well, that's useful in the end in multiple ways. It allows us to do caching, so well, good. We don't hammer the other side, and also allows to get that information translated on the domain controller. So things like ID mapping that, for example, Volker mentioned this morning, get resolved in a central place, and you don't have to configure every single client to do that. And yep. Yeah, so that's an extended operation that we do over LDAP. We define our own operation. Yeah, we had two ways to go about that. One way was to basically use Samba and do the RPCs over there, but it wasn't really the best way to go. It wasn't efficient because the RPCs only allow you to resolve one name at a time. Yeah, you could, but then you have to stand something you don't control. And so we went by, well, we have to do something custom. We just created a new LDAP extended operation, which is documented on the freeipa.org side. You could implement it if you wanted to, and then the server will just make the request, format the request, and then download the information. And yeah, so this is important again for getting access on the Linux side. So the user needs to come in and log in onto the Linux machine. One of the key bits of information is that it needs some information to be able to operate on the Linux machine. Linux machine, when a user tries to log in, needs really a few pieces of information. It needs a name, and it needs a user ID and a group ID, which are numeric IDs by which the operating system assign an identity to the actual process running. And it needs also things like the home directory, the shell, in case of actual interactive login. This information may or may not be on the Active Directory side. Now, if it is there, we use it. Fine, great. We don't have to do anything. Ooh, nice. However, many cases, this information is not in Active Directory because Active Directory doesn't use these things. They use their own different things. And so you have two options there. One way is to just fake it up, which we support in the client that is you have in the Linux machines, or you can set it in the FreeIPA server and then ask the FreeIPA server, well, if this user comes from the other domain, but what are the IDs? And we have a whole feature that's coming in the new version called ID views, where you can actually even override settings if you had them in ID. So basically, we essentially can control on the FreeIPA domain controller what are the IDs for user, or even override and change the user ID, change the group ID, change the home directory, change the shell, and you can have it also different setting technically for different machines. So if you had a legacy machine brought in, you can change individually for each machine this property. And finally, for my time's up, Forest Trust and Samba AD. So this work would have been a little bit easier if Samba supported cross Forest Trusts. Unfortunately, the Active Directory implementation of Samba has some limitations, and one of them was it didn't support cross Forest Trusts. And so we actually spent some time in sponsored work through CERNet to make it possible for Samba to support cross Forest Trusts as well. It wasn't really a lot of work, but it required a few months of working. Parts that were missing were these few LSA and net logon calls that I showed before, which are really important to be able to actually set up the trust. There was some work on the KDC that needed to be done because the KDC couldn't, it wasn't fully operational on the trust side, and also some LDAP objects that are needed to represent the trust to store the secrets and the cryptographic credentials to go from one side to the other. And then all the integration and testing, making sure it works with Windows and whatnot. This is almost done, this work, close to be ready. Once we're done, Samba will be able to trust either Active Directory, so you could set up a cross-forest trust between Active Directory and Samba itself, or FreeIPA, which is our interest, because one of the things we can do then is have Samba on one side managing Windows desktops, FreeIPA on the other side managing Linux servers, and they just talk to each other, and we're happy. And we can implement this thing. So the whole work is done because in many cases what we want is separation of duty and security. Users managed by the user management team, usually based on Active Directory and Windows desktop, and competing resources, which is what really we care about at Rice and Red Hat. We build Linux servers and middleware. It's all infrastructure for competing on their own side, managed by their own people that know what they're doing. They have different ways of dealing with it. One of the things I wanted to solve was not just to make Linux easy to use and manage on one side, but also resolve a political problem. In many companies, it's a little bit less now, but in many companies I was dealing with, you had the Windows groups and you have the Linux groups, and they didn't talk to each other. And then there were mandates from the top. Oh, we want to use the same credential everywhere. And the Windows group were telling you, no, you have to join your Linux machines into AD. And the Linux guy were, well, I don't know what the thing is. It doesn't work the way I want. It doesn't have the features I need. And this was a neat way to keep the fight away. I mean, they don't have to fight. They just set up a trust, and they don't care anymore. Everybody keeps going with their own business. The Linux guy keep managing Linux machines. The Windows guy keep managing the Windows machines. No fighting, no trouble. And that was the aim of this project. That's it. Any questions?
As I understand, it's only for Linux servers, right? Not for desktops.
So, okay, yeah, I understand the question. The question is whether FreeIPA can manage desktops or just servers. So technically, if you have a Linux desktop, it manages desktop quite well. This desktop, this machine, is joined to my personal FreeIPA domain at home. It's really useful. But FreeIPA does not manage Windows desktops at all. So yes, you can use it for Linux desktop. So if you want to, if you're moving away from Windows desktop completely, and you're using Linux or even Mac, I've seen some people that use it with Macs. Yes, you can manage them completely. We have actual very desktop-y features like offline authentication. So if you join your machine to FreeIPA, then you can keep logging in even if you're traveling. I can't keep logging in on this laptop, and my FreeIPA domain controller is not reachable. And there are other features like that that are very desktop-centric. But our focus in the project is mostly really about the service. But we don't neglect the desktop. We just don't care about the Windows desktop. When the Windows desktop is there, we say use the Active Directory integration through the Trust.
Yeah, but I meant the Linux desktop because I cannot manipulate them now very easily, and that will be a great tool to manipulate the Linux desktops. Like
Yep. Yeah, absolutely. It is supported, and it is part of what we do. It's just not what we focus on when we promote it, because most of our customers, at least from Red Hat point of view, most of our customers are really interested in the servers. But there are customers that use desktop, and this works with that.
Thank you.
Thank you. You mentioned CLDAP a couple times. Which Microsoft documents cover CLDAP?
When I implemented that, I knew. But if you ask me now, I don't remember. I'm sure I saw something that in there because I actually had a bug with Samba and its CLDAP implementation. And it turns out there was an ambiguity in how the documentation described CLDAP. And when I implemented it, I partly looked into the Samba code and partly looked into the documentation. And then I implemented it kind of midway. So Windows had no problems with the CLDAP package we were sending, but Samba had some problems, and we fixed that. So it is documented somewhere.
I answered that question for you in the past, I think.
Yeah, I never found it.
Yeah, there were some comments about the actual name. I think it was MSIDTS, but I think there's also something about possibly maze lot stuff. So I don't know if it's
Yeah, that's what I wanted to say. It's CLDAP is not really full LDAP. It's essentially in the Microsoft world. It's a transport for the old NBT netlogon packets.
Yeah, to some degree. It's a little bit of an ugly thing indeed.
Well,
But at
ugly.
least it's very simple, a very small thing. It requires a ton of Samba libraries to embed this little bit of information in this CLDAP packet, but it works.
I have a question.
Yep.
I already guessed the answer, but I need confirmation from you. So, wouldn't it have been more efficient to focus on just one project, like Samba AD, and make it work instead of creating a second one?
Maybe. The answer is a little bit complex. So when I started FreeIPA project was many years ago, it was like 2007. And there were a few things. First of all, we weren't really thinking about the Windows desktop or the Active Directory integration. This integration stuff came later. Our main problem was we want to manage Linux servers. We need something to replace the aging protocol like NIS that were prevalent back then, which was utterly insufficient. And we wanted decent authentication using Kerberos and all these things. So we set up this project, and at that time, Samba didn't really have much in terms of Active Directory. And it took 6-7 years to get to a point where it is kind of usable. And in those 6-7 years, there is nothing in Samba that is Linux specific. We built a ton of features that were really targeted at managing specific features of the Linux server, like the sudo integration, SSH keys, DNSSEC. These are all things that don't really belong or necessarily belong in the Samba project itself. So there were a number of, maybe if we started now, we would start with Samba probably, because it's much more mature. We don't have to build so much plumbing before we can come and build the things we're really interested in, because we weren't really interested into an Active Directory compatible thing. The compatibility thing really didn't matter to us until much later on in the project. What mattered to us was the features, and we wanted mature LDAP server, a mature KDC implementation that were already working, because we didn't want to have to mess with those bits beyond the just mere integration of parts to make them smooth and all nice, and then require an Uber guru to understand how to install this stuff. But we want to move quickly on the actual feature that would bring value to the actual Linux administrator. and that was our main focus. And that's basically what drove many of the choices we made in this project. So some people asked us in the past, why didn't you use OpenLDAP? Technical reasons also to deal with this problem of getting something that would work. The 390S server had multi-master replication when we started. OpenLDAP didn't, and it got it on 2 years later. Just couldn't use it. And so we just used what was available and working at the time. That's basically it. So today maybe we will use Samba, but we do use part of Samba in it, and we held back Samba, so I think we are happy anyway.
I mean, we can do that offline, but would it be worthwhile to explore unifying both?
So actually, we tried that 4 years ago before we started a trust project. One of the things we tried to do was, can we actually, merge them somehow, create some Frankenstein thing where, we use the same LDAP server, and it was, at that point, was too difficult to do. And the main reason why it was too difficult to do is that we created a schema in the LDAP server, in the directory server, that was suited to our needs of managing these Linux-specific features. This schema was based on standards that were pre-existing in part, and part stuff we added. So the stuff we added, we could have added to Active Directory schema as well. But the existing standard schema is slightly incompatible with Active Directory, and the layout of the information that we created was geared to our needs and is slightly different from what Active Directory has. And so trying now to do that is potentially possible, but it was a big project. And the first time we tried, we failed. It was taking too much time, too much resources, and we weren't getting nowhere. And so we switched gear and said, okay, let's let Active Directory or Samba AD do the job for Windows clients, and let's just do the trust stuff. So we tried that, we failed, we could try it again. Now we are more mature, we have more understanding of some things, and part of it will be done through the global catalog thing anyway. So maybe in the future.
I would love to see that.
Yeah.
Just unify forces. I mean, yeah, also the work that Nadia is doing with backing.
I'm pretty happy with Samba as domain controller for Windows clients. So I don't have a huge incentive. Part of the work Red Hat is doing is bringing, like, for example, the MIT KDC to work with Samba, and other work around Samba is toward that goal, to keep using Samba for Windows clients, because Samba is great. It works well, we like it, we love it, and so. But maybe in the future we can try to do even more. Well, I guess that you have any other question, maybe we can take them offline. And
Yep.
I guess people want to do stuff for the day.
Okay, thank you very much.
Thank
Very
you.
interesting.